Tangent line is horizontal or vertical. What are we going to examine? The first derivative. Yeah, thank you. Good. So dy dx in this case is going to be what? 2 cosine 2 theta over what? Negative 2 sine theta. So you end up with negative cosine 2 theta all over sine theta. So it's going to be tan is going to be horizontal when what? Negative cosine 2 theta is equal to 0. So that's when cosine of 2 theta is equal to 0. So that's when 2 theta is equal to what? Cosine is 0 when what? Pi over 2 plus what? Like how often does cosine? Pi n, right? Pi n, correct? And then you know that the tangent line is vertical when sine of theta is equal to 0. So that's going to be at 0 plus what? Pi n, right? I'm sorry. So yeah, up here, thank you for pointing that out. He pointed out that this is still, that's correct so far, right? But we're not done. So what should theta be equal to? Pi over 4 plus pi what? Pi over 2 times n. Yeah, there you go. So you know tan is vertical here and it's going to be the tangent line is horizontal. It's the tangent line. Now, is that what you had a question, like where those values came from? Oh, it just didn't give it to you? Yeah, okay. So you know, hold on, you know the tangent line is vertical, it's going to be when you're at the x-axis. Because at 0 and pi, theta, 0 is the x-axis, and theta being pi is the x-axis. So you end up with a shape, I think it looks like a little bubble. To this, it starts in this, it's a little, like a sideways figure 8, right? Okay. We're going to find the area bounded by those curves. We need to remember, what was that formula we had for, or what was that statement for the integral? We're going to go from alpha to beta of what? Oh, I want to make that a nice beta. Alpha to beta of what? G of t, which is that y function, times f prime of t dt. Right. So in this case, g of t is going to be what? E to the t. And f prime of t is going to be what? Secant of sine t. So you're going from 0 to what? Pi over 2. They're giving you the t values, right? They're giving you the t values. So 0 to pi over 2 of, you put the negative on the outside, so you get e to the t, sine t, dt. Now here's, and the lines y equals 1 and x equals 0. How do those come into play? This is too much though, right?
So it'll be it'll be e to the t minus 1.
Yeah, exactly. So all you're doing is you're cutting off that little bit, right? Does everybody see what's going on here? So what should we change it to? It should be negative 0 to pi over 2 of what? Minus 1 times, what was it? Sine t dt. Do we think that's right? Now, and then we did parametric, which gave a time, like an index component. So not only do we have a path, we have a direction, a time where the point is on the path. We're going to go back and describe points in space a little differently. Instead of having a horizontal position and a vertical position, we're going to have a distance from the origin and degrees from the positive x-axis. So this point, radians, you can say radian, yeah, that's a good point. We're going to be in radian unless very specifically said otherwise. So here's the deal. This point P is at r theta. R is the distance from from the point P to the origin, and theta is the number of the radians from the positive x-axis to the ray that you get when you connect the origin to the point P. That's it. You have this method of describing points in space because some shapes have really nice symmetry across the origin, and it's much easier to describe some shapes with polar coordinates. I could go grab some polar paper, but let's just get the basic idea here. If we wanted to plot that first point, the r value is, what's the r value? 1. So let's go out to, let's say this distance is 1 right here, and then we're going to 5 pi over 4. So if I go all the way to here, how far have I gotten? How far have I gone? Pi. So how much more do I need to go? So the point is right there. That's the point right there. You've gone a total of 5 pi over 4 radians from the positive x-axis. 2 comma 3 pi. What's that one going to be? You go out 2 instead. So let's go out 2. Let's just call that one 2. And what's 3 pi? Well, you know, all the way around is 2 pi, so how much more do you go? So you've gone all the way around, and you've gone back to here. So there's your point. What about 2 comma negative 2/3 pi? I can still hear you even if you're speaking another language and whispering. We're at 2. Oop. We're at 2. And negative 2 pi over 3. So instead of, you go backwards, right? 2/3 pi, so right about here. Sorry. There you are. So negative 2 pi over 3. And then negative 3. So instead of going to the right, you're going to go to the left. So where do you start? This, yeah, the left side, sure. It's at negative 3. And then from here, where do you go? Do you go clockwise, counterclockwise? Which way should I go? Okay, so I start. Now the question here is that we have to decide. We're starting there. Do we go 3 pi over 4 from here? Or do we go, I'm sorry, it jumped again. Or do we go 3 pi over 4 from the positive, from this way? Which way do you think it is? You're going to start at 3. You're going to go 3 pi over 4 to here. And then you're going to march it down right here. That's where you're going to go. All that negative 3 does is reverse the, you can think of it as a vector, and it's just flipping it over. That's it. One of this right here. What? Converting to Cartesian, right. So if you have a point at r theta, if you want to convert into Cartesian coordinates, you know that cosine of theta, what does cosine of theta equal? X over r. And we know that sine of theta is equal to y over r. So that's where you get these right here. So this allows you to convert from polar to what? Cartesian. Exactly. Do you guys see any other relationships in there? You have a right triangle. So what other relationship can you pull out of there? You have a right triangle. So what other? Oh, okay. So you could say tangent theta is equal to y over x. What's another one? Exactly. X squared plus y squared is equal to r squared. Exactly. Exactly. So what does that allow you to do? Well, it allows you to do a whole bunch of converting between Cartesian and polar and going from polar to Cartesian. Exactly. Convert the point 2 comma pi over 3 from polar to Cartesian. How would you do that? Well, you know that x is equal to what? X is equal to r cosine theta. So what does that mean? X is equal to 2 cosine pi over 3. And y is equal to r sine theta. So y is equal to 2 sine of pi over 3. What's cosine of pi over 3? Oh, come on. 1/2. Yay! We're in AP Calculus BC. That took too long. What's sine of pi over 3? Yeah, root 3 over 2. Exactly, right. It's kind of like those questions you should have automatic answers for. You know? Yeah. Maybe the really basic trig stuff in the first quadrant. Let's have that. It's right here. 1, -1, and I need you to go to polar. So you need r. It's not that bad. This one's pretty good. You need r and theta. What's the r value going to be here? Well, you know that r squared is going to be equal to, it's going to be root 2, I agree, is x squared plus y squared. So r is equal to the square root of, and again, r is always, well, you can write r as being negative, that just reflects it, doesn't change it. So we have r is going to be equal to the square root of 1 plus 1. So you're right, r is equal to root 2. And we know going back 1 and down 1, we know that theta, just off the top of our heads, what's theta going to be? You go pi, and then you got to go 45 degrees more, right? So what's it going to be? Pi. It's positive, guys. You're going rotating pi, and then you're going 1/4 more. So what is that? Stop it. 5 pi over 4. Yes, there's lots of different ways. There's an infinite number of ways you could do this, right? It's negative 68,498 1/4 pi. I don't know. I understand what you're trying to do. I had a friend in, so yes, it's 5 pi over 4. Now, how do you do that? I have a question. So how do we actually find theta? So we knew that one. We just knew that one, right? how would you actually find theta if you needed to do it out we did that one in our head, right? How would we do it algebraically if we needed theta itself? You could draw the triangle and use trig, right? Oh, look at this. Hold on. Arctan. So you know that tangent of theta is equal to what? Y over x. So we know that tangent of theta was equal to, in this case, what was it? It was 1 negative 1, right? 1 negative 1. So it's going to be negative 1 over 1, which I knew it was negative 1. I just wanted to write it out properly. But then you need to know tan inverse of negative 1. Exactly. In that case, you want the first one in the third quadrant, which is going to be 5 pi over 4. We've been thinking, look, what's the point? It's 1 negative 1, right? Over 1, down 1. So what quadrant are we in? Fourth. We're in the fourth quadrant, right? We're definitely in the fourth quadrant. When I was doing this, I was putting in the third quadrant. What were we looking at as kids? We were just, no. Yeah, we were looking at it as negative 1, which is not what it is. We actually got to redo this. We were looking at them as both being negative. So is it 5 pi over 4? No. Well, it's negative pi over 4, which is the same thing as 7 pi over 4. Thank you. So it's the second, yeah, it's going to be the one in the fourth quadrant. So it's actually going to be 7 pi over 4. So the only point of this is you have a function where it takes the graph of a polar equation is r equals some function in terms of theta. The radius, the r value, right, the distance from the origin is some function in terms of theta. So as you sweep out, something happens to the distance you are from the origin. So what curve is represented by the polar equation r equals 2? What curve is that? If the radius is always equal to 2, no matter what theta is, what is that? That's a circle with radius what? Circle with radius 5 halves, right? Something random, I understand. So in this case, you know this off the top of your head. What is the equation of a circle with radius 2? X squared in Cartesian coordinates. X squared plus is equal to? No. 2 squared. Yes, 2 squared. X squared plus y squared is equal to 2 squared. How would we get that? I have a question for you. How would you get that equation given the relationships we already know? What do we already know? What was that one thing you put down? Where is it? You know that, right? You know x squared plus y squared is equal to r squared. So if you know it's just r, you're done. Okay, so what did I say? Are some curves that we've dealt with a lot easier when you're dealing with them in polar coordinates? Yes. Sketch the curve with the polar equation r equals 2 cosine theta. So put your calculator down. Don't touch the calculators, everybody. How would we go about graphing this if we wanted to graph this? If you wanted to graph it without your calculator. Yes, I'm going to let you do it for most of them, but not this one. How would you do this? What can you always make? Table. You can always make a table, right? You can always make a table. Okay, so you could make a table, connect the dots, get an idea. How would we do this if we wanted to make this into a Cartesian equation? What would we do? Algebraically, how would we do this? R equals 2 cosine theta. So what do we know? We know that x squared plus y squared is equal to 2 cosine theta squared. Do you agree with that? So you know that x squared plus y squared is equal to 4 times what? Cosine squared theta. Okay. Now, what's the problem with that? Are we in Cartesian form? Yeah. Not really. We're not in Cartesian form. We know theta in terms of x and y. So what do we know? Okay. How about this? Let's avoid trying to put in arctan, okay? There's other ways. Let's avoid arctan. Yeah, the problem is we just don't like having theta, x, and y. Which one, if we could get rid of one, would we like to get rid of? We really would love to get rid of theta, right? So we'd love to turn theta into what or what? Turn into x or y. Well, what do we know x is equal to, kids? Theta. And what do we know y is equal to? So if we know that x is equal to r cosine theta, x is, what does r equal? 2. Well, what is r? 2 cosine theta times what? Times cosine theta. And hey, we know that, yeah, what does y equal to? 2 cosine theta times sine theta. Which one do we actually want? Hey, we have this right here. So what is x? Oh, x is equal to 2 cosine squared theta. So what can you do with that? Nice. So what do we now have? X squared plus y squared is equal to 2 times x. So we have x squared minus 2x plus y squared is equal to, so we have x squared minus 2x plus 1 plus y squared is equal to 1. What did I just do? Not 0. What is that? I completed the square is what I did. So what is that right here? What is that right there? That's a circle. No, it's not a function. Circle with radius what? 1. With origin what? 1, 0. Bingo. Bingo. With origin 1, 0. Okay, so you're asking why do they mix and match? Why do we just have? Why do we have the same words meaning different things? How about this? With center. But why? What? Yeah. So we have dy dx if we have y in terms of theta, and x in terms of theta. But the point is, you usually have it as you have dr theta. So what does this give you here? This is just the formula right here. So here's the thing. You know what? You know that dy dx is going to be equal to dy d theta over dx d theta, correct? But what does x equal? X equals r cosine theta, and y equals r sine theta. So when you do the differentiation, you use the product. You use the product rule. The derivative of the first times the second plus the first times the derivative of what's the derivative of sine? Cosine, right? Parentheses? No, that should, because you know that, remember, x equals r cosine theta, and what does y equal? You see that right there? Got it. So what this allows you to do is to do that first derivative and get dy dx, but start with the polar form of the curve. It's nice. You have to remember this. This is important.